Is Eric Lawrence. I'm a software engineer on the Chrome security team. Prior to working on Chrome, I worked on Fiddler for Telerik, but now I've sort of moved on to another passion of mine, which is securing the web. And these days, primary part of that is HTTPS. And so, one of the things that comes up a lot when talking to product teams and companies about moving to HTTPS is, why do we need to bother? HTTP works. It's been around a long time. My site isn't that important. Or my site isn't, I'm not collecting people's private information or credit card numbers, so why should I care? And fundamentally, the reason that sites should care about HTTPS is it's the only way to truly ensure that the experience that the customer is getting is the one that you set out to build. Okay, HTTPS is, I like to call it the high fidelity of the web. Like, if you don't have HTTPS, you just can't be sure what customers are getting. And it's important to do HTTPS everywhere, no matter what kind of site or service that you're building. And we're going to go through some examples of why that is. But one of my favorite quotes is from, the American government has a CIO office, and they basically set out, hey, there's all sorts of websites. And these days, there's no such thing as a non-sensitive web traffic. And public services cannot depend on the benevolence of network operators. Okay? We can't rely on the guys that are running the networks in the coffee shops or the ISPs and so forth. We can't rely on them being benevolent, and there's good reason not to. Now, when I set that out, oftentimes people are like, yeah, okay, academically, maybe that's true, but is it really true? Are there real-world threats? And the answer is yes, there are. And they range from the somewhat innocuous to the very serious, to the beyond serious but not terribly broadly a concern. And so the first one is ad injection. And you don't really think about this necessarily if you don't go out and use other people's networks very often. But there are actually networks where when you're surfing on their network, they will inject ads into your web traffic. So, with coffee shops will do this and so forth. It's a monetization strategy of, hey, you get a router for free, and our router will inject ads into the traffic that goes through it, but you don't have to pay us. And so this is actually a thing. And we have screenshots of, for instance, the Apple web page trying to sell people Android phones. Because guess what? The ad has been injected by the network operator. And so if you're building a commerce site or something, not even during checkout, do you want people trying to lure your customers away? Of course not. There are enhancements. Enhancements I put in quotation marks. So if you're flying on Southwest Airlines in the United States or a couple other airlines, if you're browsing non-secure pages, they inject a little toolbar into the page that's like, hey, here's your progress on your flight, right? They're not trying to be malicious. They're not trying to be evil. They're trying to provide a value add. The problem is, of course, that value add, if it's not coded perfectly, can interfere with your web page from a technical point of view, but also from a user experience point of view. Do you want the user to fail to complete their transaction because they realize, oh, we're going to land in 5 minutes, maybe I'll just do this later? Of course not. So you also see this from internet service providers. So people who are on capped connections or, hey, this is how much data you get this month. The ISP will push down a notification of like, oh, by the way, you're about to blow your data budget. Maybe you don't want to be here. And you don't want that on your page either. Then you get into some of the more malicious and commonplace things. So you've got things like SSL strip, and prior to that, there was a popular plugin called Firesheep. Have you guys heard of Firesheep? It's less of a deal these days. But Firesheep is this Firefox plugin. You basically go to a coffee shop, and you'd start up Firesheep, and Firesheep would just watch the unencrypted network traffic of the people around you, and it would collect their tokens for Facebook or other social networks, and then put them in the cookie jar of your current Firefox browser. And then you can browse as someone else. You can basically adopt that person's identity just by sitting next to them on an unprotected network, grabbing the unprotected HTTP traffic. Now, this is less of an issue now because most of the prominent social networks, things like Twitter and Facebook and so forth, all use HTTPS. But the same general principles apply for other scenarios. And so if you're on an unprotected HTTP connection, anybody that's on the same network and in a privileged position can see that traffic and can see what you're doing. And so we don't want that. Another scenario is denial of service, distributed denial of service attacks via script injection. So there are countries in the world that have problems with certain kinds of content on the internet, whether it's a news story about something that the government of that country has done, or just other information that they consider undesirable. And so they might try to take down that content by kicking it off the web by doing denial of service attacks. And so if you're in a country, large country with lots of people that has some sort of large, we might even call it great firewall, they might actually inject script tags into unprotected HTTP pages that make the users that browse through that participants in a distributed denial of service attack against content they don't like. And so we saw this actually happen, where there were two websites that were hosting content that this government didn't like, and they got essentially tens of millions of clients effectively pushing denial of service attacks against that content through script injection. And so the sites that were vulnerable, the HTTP sites that were actually running these scripts, were not in any way participating in this scheme, except that they were using non-secure protocols, and so these script tags got injected. So you don't want your site to be used in this way, obviously. Then you get into privacy concerns, and people are like, oh, privacy, I don't really do anything interesting, I'm not very interesting, the government would never bother, following me, and even if they did, who cares, it's really boring. Well, the answer is, actually, pretty much everyone's traffic is interesting to someone. And we got a great demonstration of this in the United States, where we have a fiber ISP that basically says, hey, we just look at all your HTTP traffic, and then we create a profile of you, and we effectively sell that to advertisers. And if you don't want this, you can opt out, right? That's cool. But we're going to cut your discount. You're going to pay $29 more a month, okay? So that's $360 a year that effectively is their value of your privacy. And so even if you think, hey, I'm not doing anything interesting, it's still true that this privacy profile, the impact to your privacy, is worth real money to the people that are interested in seeing your traffic. And so that's why, for instance, your ads might be very personalized. And some people are like, great, I love personal ads. And other people are like, wow, it's super creepy that every website seems to know that my wife is pregnant despite me not saying anything about it. Right? And so in some cases, that's a trade-off people are willing to make. And in other cases, $360 a year for privacy, they're not very happy about that. Then you get into some more dire scenarios, like malware injection. So this is less common than it could be, and hopefully it stays that way. But there have been cases where people, particularly targeted individuals, are, they're surfing around and they're like, oh, hey, I want to go get the latest version of this executable. And they go to download the executable, and they don't just get the executable, they actually get a wrapped version of the executable that, in addition to installing whatever they were trying to install, also installs a little bit of malware on their machine. Now, this can be foiled with things like code signing and so forth, but there are so many flaws in the various mechanisms that are being used for code identification and user experience that malware that is delivered in this way is actually very, very likely to get installed. Now, it's not terribly broad. But for somebody that's being targeted for some reason, industrial espionage or other types of espionage, it's actually very effective. And then we have this notion of global adversaries. Okay, so you've got the Snowden leaks and everything else, where it turns out that certain governments are very interested in understanding what everybody's doing at all times. Not necessarily because they're being targeted, but because they're looking for patterns or trying to find associations. And some people get really uncomfortable at this notion. Other people don't care at all, again, like, oh, I don't care if the government knows what I'm doing. But certain people have real problems with that happening, particularly if it's not your government. So, moving along from that, we also have this notion that the web platform is getting more powerful. So, on those of us sort of in the web space and the web platform, want to be able to do everything with the web that you can do with native applications today, right? So we want this open web concept to allow competitiveness of applications that are not tied to, iOS specific or Android specific or Windows specific and things like that. And so we're putting more and more powerful capabilities into the web platform. So things like audio and video via get user media, the user's geolocation, things like service worker for persistent local proxies, device access for motion, orientation, encrypted media extensions for media protected playback, app cache, things like that, right? So we're getting more and more power into the web platform. But these powerful capabilities on the web suffer from one problem that native apps don't. Native apps come down from the store, it's signed, it's code signed, you're sure you're getting the right thing. But if you're delivering your web application over HTTP, there can be no guarantee that these accesses and capabilities are being used in a secure manner, right? So we need HTTPS to ensure that what you're getting in the client is what the original developer sent, and it really came from that original developer, and it hasn't been augmented with any additional functionality on its way to your device. And so we're starting to require HTTPS for those APIs and capabilities. So a couple of years ago, the deployment of HTTPS on the web was not very good. Over the past several years, however, there's been a ton of progress. And overall, we can summarize the progress of things as up and to the right? So whether you're looking at the percentage of pages that are loaded over HTTPS, either absolute or weighted by traffic, or the amount of time spent on pages, right? Maybe I load a bunch of HTTP pages, but I'm just clicking through, I'm not really doing anything with them, versus an application like Facebook, where I load Facebook HTTPS that's one page load, and then I spend 15 or 20 minutes on a single page. If you're looking by country, certain countries are accelerating the move to HTTPS faster than others. And by platform. And platform is an interesting one. So we in Google, we publish what's called a transparency report for HTTPS. And we break out the traffic by platform. And you can see that we follow this general trend, again, of up and to the right, where traffic overall is moving to HTTPS, but it's moving by platform. And so one of the things that you'll notice is Android is lagging the other platforms. It's still now over 50%, but it took longer to get there than other platforms. And the reason is that the head of the web is well encrypted, things like Facebook, Twitter, and so forth. HTTPS, been HTTPS for quite some time. But on the mobile applications, or on the mobile devices, you usually are using an app to interact with those. And so the percentage of time that you're spending inside HTTPS at the head of the web is lower because you're using apps for that. And so we are seeing that those mobile platforms are taking longer for the browsing traffic to get to HTTPS because people are spending more time in the tail of the web that's not encrypted. This is by browsing time, and you see sort of the same trend. This is not just Chrome. Firefox is seeing the same trends as well. They're seeing that 64.66% of the page loads in Firefox are HTTPS, and that's been going up over time as well. The tail of the web, despite lagging, is actually making great progress. And so that line at the top, the red line that's kind of swirly, is sort of the long tail of the web. It's the Quantcast, it's the built with top million sites. And so the number of those sites that have moved to HTTPS has increased dramatically. Even as it trails over as a percentage over the head of the web, the top sites on the web, the tail is getting encrypted. And the reason that we're seeing sites move to this is because in the browser space, there are new goodies available to sites using HTTPS, but new enforcements against those that aren't. So the first one is the lock icon. Lock icon has been around since the days of Netscape and has evolved relatively little over the years. In Chrome 52, I think it was, or somewhere around that time, we started actually explaining what the icon meant, and so we say secure. Secure is a bit of a lie, unfortunately. It's really more like private, but various user testing was done, and we settled on secure. But you think, okay, well, why do you even need text there at all? And the answer is, it turns out that there's quite a lot of people that don't know that that was a lock icon at all. Oh, well, that's a handbag, because I'm on a shopping site. And you think, that's ridiculous. There's no way anybody believes that. We actually had that happen over and over and over. We have some people in the Chrome security team that have like the lock icon on shirts and jerseys and things like that. And people are like, why do you have a handbag on your shirt? And so the answer is, well, it's a lock. And so understanding of what that means is actually something that was not necessarily as high as we'd want. So we started being a little more explicit and verbose about what icons meant. One of the things we used to have is, if you're on an HTTP page, you just have like a blank square, a little rectangle was the default icon up in the security indicator. And we changed it to just an eye and a circle. And our theory was that, hey, we actually have something to say about this. If you click on it, we say your connection to this site isn't secure. So we just changed just the icon from the rectangle to this little eye. The support forums lit up. Oh my God, why is my web browser not secure anymore? I've been going to this site for years, and now it's not secure. What happened? And the answer is it was never secure. If you clicked on it before, you'd get exactly the same thing, but nobody knew to click on it. Now that they clicked on it, they're like, wait, what? What? Huh? This is supposed to be secure. I expect this to be secure. What are you telling me? And so just by doing very subtle changes in your UI, we can actually have a big impact on user behavior and understanding. Now we have features like autofill. Autofill for web forms dramatically increases conversion for websites. Like if you're going to go check out someplace, you're like, oh, I want to buy this shirt, but I don't really web form. Oh, look, just like one click, I can fill in my credit card, my shipping address, and everything. That's awesome. It's only available on HTTPS. And if you have a page that tries to use this on HTTP, you get a little nag that's like, sorry, can't fill this, it's not HTTPS. So we're doing subtle things like that in new features. In Chrome 56 a while ago, we started introducing a new not secure warning. So instead of just showing the eye icon, we say not secure explicitly in text next to it on pages that have credit card or password fields, under the theory that these pages are more likely to be interacting with sensitive information. And we sort of want to draw attention to the fact that, hey, this is not really providing the security expectations that you might have. And so we started, it's called the verbose state. And so we started notifying users about these pages. In Chrome 57, we started an experiment that didn't ship out in Chrome, but it's actually turned on, a very similar thing is turned on in Firefox, where if you start entering your credentials into a page that's not secure, there's a little drop-down that appears underneath the box and says, keep in mind, not secure, login's not secure, this data might be intercepted in transit. The Firefox text is quite similar. And the same thing happens for filling in credit card forms. Credit cards actually turn out to be not terribly common. People have known for a long time they need to encrypt their credit card information. But for a long time, there was this persistent misunderstanding of, oh, well, I'm collecting the username on this HTTP page, but I'm going to send it over an HTTPS connection to the server, and it'll all be good. Neglecting the fact that your page that had the form might have been intercepted and changed to collect the credit card or the user's private information and send it somewhere else. And so the warning is on the page of collection, not on the page of receipt. It's pretty easy to fix these, and we actually got a bunch of sites where their login, they weren't ready to move to HTTPS, but we just make the login button, instead of doing these fake overlays on the page, you just go to a different page. And the different page collects the information securely and sends the user back non-securely if they need to. But our real push is to get sites to just be HTTPS for every page. So in Chrome 62, which started shipping a couple of weeks ago and will be hopefully completely rolled out very, very soon now, we've actually gone further. And so anytime the user is typing into a form field on the page, we will say not secure up next to the Omnibox, up next to the little eye icon. And so this is actually pretty noticeable at first. The first time it happens, people are like, wait, what? So basically, you go into the form field, you start typing, and boom, it says not secure across it. And so this happens on some tail sites that you would sort of expect. You're like, oh, yeah, this is kind of a little lame site that was built a couple years ago. But it's also kind of interesting because it happens on some top sites, like Bing. Bing made a change. I noticed in the airport on the way here. They look at your user agent string now, and if you're using Chrome version 60 and later, they automatically redirect you to HTTPS. But if you're using an older version of Chrome or using Chrome on Android where this warning is less prominent, they keep you on HTTP. Don't do this. I'll mock you. I'll make a big deal out of it because it's ridiculous. Go to HTTPS. The other part of this change is that if you start browsing HTTP pages in incognito mode in Chrome, we say not secure all the time, regardless of whether or not you've interacted with the page. And the notion there is that if you're using incognito, you've sort of told the browser, hey, I'm doing something that may be sensitive. I'm banking or doing other traffic that I would prefer that it's more sensitive. And so we want to draw attention to the fact that the connection that you have to the network is not secure. And so you can make your decisions accordingly. From a developer experience point of view, we tell you, hey, in the developer tools, this page is not secure, and if there's something that's lit up the Omnibox, change that to that verbose text. We'll tell you what it is. So like, hey, there's private user data on this page, so you're trying to collect a password or something like that, or the user is interacted with a form field. Now, one of the things that we encounter is developers are like, yeah, I get why this is on the public web, but I'm doing this on my private internal network, and I don't want to go get certificates for anything. It's really kind of a pain. So there's a couple things that are being done in Chrome around this. So for instance, localhost is considered a secure context now. So if you go to HTTP localhost, we're going to treat that as a secure context, and we're not going to light up warnings and things like that because it's on your local machine. But maybe for whatever reason, you need to hit your machine using like HTTP my machine name. So one of the things that you can do that I think is kind of cool is in Fiddler, it's literally this simple to use a valid certificate to serve to your own machine. You basically create an autoresponder rule that says, hey, for whatever domain name that I want, just automatically serve out of this local file folder, right? And so you've got a web server in Fiddler sitting on a local machine, and because Fiddler generates self-signed certificates and automatically trusts its root certificate for the current operating system, you make all the HTTPS warnings go away, and you're hosting a legitimate HTTPS site on your own machine. And so you can do things like this that make it very simple. There are also command line arguments available to Chrome where you can tell Chrome, hey, HTTP fuzzle is a secure context, even though it's not using HTTPS. It's a command line thing that has similar behavior. The reason that I think it's cool to do in Fiddler is not just because I wrote Fiddler, but because this works across browsers, so you don't need to worry about, oh, this is going to behave differently with Firefox, or this is going to behave differently with Internet Explorer. You can just do this. Fiddler offers some other capabilities for certificates in HTTPS as well. You can look at certificate chains. There's a plugin called the Certificate Analyzer that allows you to look at the complete chain of certificates and ensure that the dates and so forth are as expected, and that you're using the signing algorithms and other capabilities that you think are appropriate and interesting. We'll talk a bit more about some other tools shortly. Now, long term, here's our goal. We want not secure pages in Chrome to have the red scary thing with the bang in it that says not secure. We're not there yet. We don't have a timeline for when exactly we're going to land there. Our goal is, as much as possible, put as much traffic on HTTPS such that users see this warning rarely, and when they do, they take note of it. We don't want to light up a significant portion of the web and tell everybody that it's not secure. It's not good for warning fatigue. It's not good for the outcomes that we want. But so far, we've been very effective in increasing, as you saw in those earlier charts, the percentage of sites that are on HTTPS just by making very small UX tweaks. It's not just Chrome. We're not sort of crypto fetishists that are like, oh, we want crypto for everything just for its own sake. Other browsers and platforms are doing the same thing. Firefox actually sort of kicked it off with a rather boldly titled deprecating non-secure HTTP post a few years ago. And they've been doing similar tweaks in their UI to help guide sites over HTTPS. Apple has started, they announced they're going to start requiring for HTTPS connections for their iOS applications by the end of 2016. I don't think they've actually flipped on that enforcement, but certainly they're moving in that direction. And then Windows has started in their app platform requiring HTTPS for a variety of things as well. So it's not just us. Now, historically, there were a bunch of reasons why sites didn't go to HTTPS. Oh, it's going to mess up my ad revenue, my CDN doesn't support it, or it's going to charge me a whole lot of money, other things. Overall, what we found is content delivery networks are now doing a fantastic job, for the most part, in getting sites over to HTTPS. The best, perhaps, of them in terms of share is Cloudflare. So Cloudflare makes it very easy to front your site with HTTPS. In many cases, it's a few clicks and you're done. Other CDNs, you go and say, oh, well, we're going to go look and see what it's going to cost to light up HTTPS for our CDN. And you look, and it's like, it's going to cost 3 times as much or 10 times as much. You're like, well, clearly I'm not going to do that. One of the things we found is that you need to be very, very precise with your CDN about what you want. There's a very popular CDN where they quote you a rate of 3 times as high, and then you actually say, no, 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 I don't want to move up a tier. I don't want your super duper monitoring, extra geolocation pops, and so, things like that. I just want HTTPS. And previously, it's a feature of your higher tier, but I want to know the tier I'm on. And with some cajoling, they'll actually give it to you at a very, very low marginal cost over what you actually have. And so if you're getting an answer from your CDN that seems unbelievable, it probably is. You can probably get it cheaper. Advertising. Historically, there were different markets, as it were, different auctions for ads that were on HTTPS pages versus HTTP pages. The HTTP auction was much larger, and so the prices were higher. That has generally gone away. All the ads that Google has are available over HTTPS. They all participate in the same market. So whether it's AdWords, AdSense, DoubleClick Ad Exchange, all of that traffic is now in the same auction and commanding the same rates. Overall, the Internet Advertising Bureau, back as long ago as 2014, said, like, hey, we think HTTPS is the best practice and people should be using HTTPS. And as of the end of that year, quite some time ago, 80% of the ad traffic was available over HTTPS. There are a few laggards, but they're getting more and more rare. Another concern is search engine optimization. Overall, there's this idea in Google of fair results, and as a result, on the Chrome team, I don't get to talk about search engine optimization, but there are some blog posts from people who do, and so this deck will be available online. You can take a look at it. These are 2 great links about it. Generally speaking, as long as you do your migration properly, you're not going to see a significant hit to your search engine optimization. Your existing weight and so forth will carry over. There are ways to get this wrong. There are things that you can do that will break you. We have seen sites that do some things where they have a robots.txt on their HTTPS site that says, don't index me, and then they flip their site over HTTPS and their site disappears from the internet. Oops, don't do that. So there's some guides and walkthroughs on how to do this properly so that you're not going to hurt your search engine rank. And we've worked with a lot of major sites that did make the move to help ensure that they did, in fact, keep their reputation. And sometimes there's a little dip. One of the things that's worrisome is there's often cases where people did it wrong, and they write this inflammatory blog post of we moved to HTTPS and it was horrible and we lost all of our users and visitors. And the answer is, no, that's not what happened. What happened is you either made a mistake, that robots.txt thing, or you did sort of an invalid experiment. So we had one site, it was a news site. They're like, well, we're just going to move this one section over to HTTPS, and then we're going to look at what happens. And what they ended up doing, though, is it's a news site. Nobody visits old articles. They visit new articles. And so what they did is they compared the traffic of when the articles were new on HTTP versus when they were old on HTTPS. And they're like, oh my gosh, our visits went way down. Well, it's not a valid experiment. You need to experiment in a way that you're actually looking at numbers that are meaningful. However, HTTPS offers a variety of ways to shoot yourself in the foot. If you introduce errors in your HTTPS configuration of your site, your traffic will fall, users will not visit, users will get scared away. There are a variety of perils to watch out for. Incorrect certificate information, expired certificates, missing intermediates in your chain, mixed content. And we're going to go through how to avoid those. So let's go to HTTPS. First thing is, why TLS? Understand why and where change is needed. So I made my case for why. Your sites may have different reasons. But where change is needed is important. Overall, our position is everywhere. But certainly there are priorities. Anything that's dealing in any kind of sensitive user information or sensitive content. BuzzFeed was one of the early movers to HTTPS because they have content in particular topics that governments might be interested in understanding who's reading these topics. That might tell us something interesting about those people. And so they moved to HTTPS because they want to protect their users' privacy in terms of what they choose to read. And so understand the prioritization. Next, try TLS. So you acquire certificates, you deploy your initial configuration, usually on a dev site, and then you test it to verify that you've got performance and that your certificate configuration and everything else works properly in browsers. After you've done that, typically what you'll do is you'll deploy it in parallel on live. So you've got example.com, you'll stand up HTTPS example.com. You won't tell anybody about it, you won't drive your traffic to it, you won't change your canonical hrefs in your search engine optimization, things like that. You'll just put it out there and let some traffic naturally flow there. You'll do an experiment. And so we've seen major sites that do this, where they'll just say, we put it up just to see what would happen. And it turned out about 1% of visitors sort of naturally ended up going to HTTPS, either because the user, organically tried HTTPS first because they're security conscious, or, they just happen to get a link from somebody. And then they'll tune. They'll basically say, okay, well, what do we see here? Errors are up, errors are down, what's happening? And then they'll tune their deployment. After they do that, they start to say, okay, well, we're going to go to HTTPS by default. And so we need to make sure that we get rid of mixed content. It's going to take away our lock icon or break our pages if the content is active. And then ultimately, once you've got a deployment that works, you go all TLS. You add strict transport security headers, and you say, okay, all of our traffic is going to be HTTPS. We're going to upgrade all our canonicals. We're going to make all HTTP visitors go over to HTTPS. And this is pretty much it, 5 steps. Now, one of the things that has really helped in this move is that there are more and more cases where you just have free automatic certificates and configuration. Let'sEncrypt.org is sort of the pioneers in this space and certainly the biggest player. Let's Encrypt is a free automated open certificate authority, where basically you run a little module on your server, or you can get certificates in other ways, but the most common way is you just get a little module on your server, automatically goes out, obtains and configures certificates for your site. And you just run this thing, and bam, you've got an HTTPS certificate for your site. Their growth is huge. This chart largely explains where the growth in HTTPS and the long tail of the web has come from. It's from Let's Encrypt. Huge number. I believe they crossed 100 million certificates. Automatic certificates are available from many hosts these days. WordPress, even custom domains. They actually do the work to go out and get your certificates for you, and they configure them on your site, and it's a checkbox, literally. This is coming to sites and platforms that were previously not available because the automatability of Let's Encrypt is high. And then there are tools like Mozilla's SSL configuration generator that can help you configure your web server software so you're going to get optimal security and the broadest compatibility. There are automated checkers that are fantastic for helping you ensure that the site is going to work correctly. One of my favorites is SSL Labs. SSL Labs, you go in, you type in the URL, it goes and probes your configuration, figures out whether you got the right ciphers enabled, figures out whether or not your certificates have the proper chains and you're including the right certificates. If it finds problems, it will warn you about them. It's a great site. Mozilla's TLS Observatory is very similar. And then there's a product that's a commercial product called Hardenize, which does more than just TLS configuration. It'll look at your DNS records. It'll look at other configuration issues on your server and find security problems. So these are fantastic. I use SSL Labs every time I look at a website that I'm helping move to HTTPS. You can find all kinds of problems with the SSL Labs server test. You can find missing intermediates, unneeded certificates, weak ciphers, and other problems. So here's an example where missing intermediate. So when you visit a site, it gives you a certificate. But in most cases, it doesn't just give you a certificate, it also gives you an intermediate certificate. The intermediate certificate says, hey, this certificate for my site actually came from this intermediate that chains back to a root. But it's possible to send just the end entity certificate. And the problem is that if the intermediate isn't available, the trust chain doesn't actually go back to the root. Where this is particularly insidious, however, is that there are cases where browsers can't get to the intermediate. So most browsers, Windows, Mac, and so forth, on a good network connection, will just download the intermediate seamlessly and nothing bad happens. But periodically on Twitter, I get somebody saying, hey, my site doesn't load in Android. It loads everywhere else fine, but it doesn't load in Android. I get a cert error. And the reason is that Android historically did not download intermediate certificates. And so if you didn't include the intermediate in your chain, you got a broken trust chain. Now, someone on my team actually recently fixed that. The latest versions of Android will actually download the intermediates for you, but if you've got legacy devices, or in the event of poor network connections. So we had a guy on a Mac say, hey, this site isn't trusted on my Mac, what's going on? And the answer is his network configuration was not good, and his attempt to download the intermediate failed. So it'll tell you about this and say, hey, there's an extra download in your chain. You probably want to fix that. Other cases are if you've got weak signatures, so you've got a SHA-1 certificate somewhere in your chain where it's not supposed to be, or if you've got a weak cipher enabled. For some reason, there's a very popular CDN that for many of their sites has 56-bit ciphers enabled. You don't want that enabled on your site, and it'll tell you about those. Hardenize is based on the concept that about 1% of websites are opted into modern security features. And so it creates this report for you saying what you're doing right and helping you understand opportunities to do better. Now, in the moves that we've seen, the biggest problem is mixed content. Mixed content is when you've got an HTTPS page that pulls in HTTP content. Sometimes this just gets blocked. If you're trying to pull in what's called active mixed content, script or style sheet, the browser will just block it. In Chrome, we show a little shield icon up in the address bar, but we don't pop a notification or anything like that. It's just blocked. It's like, oops, that was a mistake. We're just going to ignore that part of the page. Passive mixed content is more common. And that's when you've got image, audio, or a form targeting HTTP on an HTTPS page. By default, Chrome will allow these things through, but it revokes your lock icon as a penalty. Effectively, you get downgraded to the little eye with a circle around it rather than getting your lock icon. And the reason is that passive mixed content is fairly common. We don't like it. We want it to go away. We would like to block it by default, but we can't at this time. And so if you want to get your lock on every page, you got to make sure that that passive mixed content is not there. Historically, this is a huge problem. There are some cool things afoot that allow you to solve it more easily. And then there's the last thing, which is a passion of mine, which I like to call latent mixed content. You go to these super secure web pages where they're following every best practice, but it turns out that half the links on their homepage go to HTTP links. And those HTTP links don't need to be HTTP links. They could be HTTPS, but the site never bothered to update them. Because browsers don't warn you about this. They don't tell you anything about, like, oh, by the way, you got that link over to Twitter, or you got that link over to your social page, or you got that link over to this other domain that you own, but you never upgraded it to HTTPS. And so I've got some tools for that. Sometimes mixed content is surprising. So the CIA or NSA or whoever does these things recently released the document cache of Osama bin Laden from Pakistan. So, you know, it's hard to imagine a site that you would hope be as secure as the NSA, but the lock icon isn't present on the page. And you're like, oh, what are they doing? And it turns out, at the top, they've got a search box that goes off to Google, and the URL of that form is http://google.com instead of https://google.com. So the lock icon gets taken away. And in the console, if you open the console, it's like, hey, the reason is because it's targeting a non-secure form. And so that one's one that bites people sometimes because they're surprised. Fortunately, modern browsers, now accommodating 76% of the global percentage, have a great option available, and it's called Upgrade Insecure Requests. So Upgrade Insecure Requests is a content security policy that you can specify in your web page that says, hey, even if I have an HTTP link, you know, image source equals HTTP whatever, just treat it like HTTPS. Automatically upgrade all of those non-secure references to HTTPS. So this works great in scenarios where, hey, we've got a back catalog of 1 million documents, and we don't want to go through every document and change every image reference to HTTPS. All the content's coming from our CDN, it's all available via HTTPS, but you only get HTTPS if you ask for it. So you can use the Upgrade Insecure Request directive to automatically upgrade those requests. And this has been instrumental in moving large sites like Wired over HTTPS, where they have this large back catalog that they don't want to touch. It's pretty easy to use. You just have your content security policy directive, and you put in Upgrade Insecure Requests. You can block non-secure traffic by saying default source is HTTPS, so HTTP requests are silently dropped in browsers that don't upgrade those requests. And then the other thing that you can do is you can set a report only. So if you have a content security policy report only with a default source of HTTPS, what that ends up doing is it will send back a CSP violation report for URLs that are HTTP in your pages. So you can go fix those up for browsers that don't support Upgrade Insecure Requests. These days, basically that's Internet Explorer, unfortunately Edge, but basically those browsers will, you know, get their security UI downgrade. You'll lose the lock in Edge or Internet Explorer because those things are not getting upgraded. If you use CSP, the non-secure requests will get blocked. But the reporting policy allows you to go fix those things on your schedule. There's another feature called strict transport security, where you can basically tell the browser, hey, when you go to contact me, if you were going to contact me over HTTP, the user just typed example.com in the omnibox or the address bar. Actually, they didn't mean HTTP, they meant HTTPS. And so you can send this directive, strict transport security, and then time, effectively, and the browser will just upgrade all requests to you to HTTPS. But it'll also do one more thing. It'll say, hey, we know what we're doing in terms of HTTPS, so if there's a problem in our HTTPS configuration, like the certificate isn't valid or whatever, don't allow the user to click through. And so the idea here is that you're a bank or you've got a site that's serving sensitive information where there might be an attacker on the network that tries to fool the user with a fake certificate and hope that they'll click through the certificate error page. What strict transport security does is it takes away the option to click through. So this is a great thing to do in most cases. The downside is that if you do mess up, if you forget to renew your certificate or something like that, the user cannot get through. Now, adherence to SSL warnings is actually pretty good. So if you mess up your certificate, you don't have a valid certificate, or it expires too soon, you're going to be in a bad place anyway. But strict transport security makes it a very bad place. Fortunately, these things tend to get fixed pretty quickly. The Fiddler suggestion site had their certificate expire last week, I think it was, and it was bad because I couldn't go make suggestions for the new versions of Fiddler, but they actually fixed it in like an hour. So it's not a huge problem, but it can turn, you know, a quiet day into an emergency day. So strict transport security is something that you really want to be careful of. There are possible footguns. So one of them is include subdomains. Include subdomains allows you to say, hey, not just example.com should be HTTPS, but also www.example should be HTTPS, sub.www.example should be HTTPS, and so forth. So this is great in terms of things like protecting cookies, because your cookies go to all your subdomains in certain browsers. And so it's cool, it's a good feature. The problem is people will often forget about things. So we've had sites say, hey, I want HSTS, I want, include subdomains, everything is secure. Except they forgot that their intranet is all under intranet.company.com, and most of those sites are HTTP. The browser doesn't care that it's your intranet. You said include subdomains. And so you've just created a denial of service for all of your HTTP sites. So you have to be very careful if you're doing include subdomains. Fortunately, the max age parameter allows you to do this in a good way. So the way you should do your HSTS deployment is you should say, I want a time of 5 minutes. Apply the strict transport security thing for 5 minutes. And then you ramp it up to 10, and then a day, and then a week. So that anything that you've got that you need to care about latently on HTTP, you can discover that in a way that's not going to brick your clients for a long period of time. I wrote a plugin for Firefox and Chrome called the More TLS Analyzer. It's literally just a button that sits up in your toolbar, and you click it, and it will find non-secure hyperlinks, and it will identify non-secure images in your page. And it gives you a one-click way to say, hey, can I just change this to HTTPS? Would it just work? You just control-click on the links that are in the report, and it will tell you, yep, that thing was available over HTTPS. Just change the link. It's good to go. So here's an example. We've got this bad SSL page, and it's got 6 links on it that are not secure. And you just click on those, and it'll tell you. Now, back when I said we should HTTPS everywhere, there's a good reason for that. And that is because people will often put HTTPS on their main domain, the thing that they care about. But then they send out these emails that are like, hey, log in to change your password for better security. And all of those go through some non-secure click tracker. So here's an example from GoDaddy where they're like, update your GoDaddy password, click here. Now their site is HTTPS. They're actually they have certificates for everything. But their email tracker is not HTTPS. And so this is a huge problem because if I'm a bad guy on a network and a user clicks on this link, they're going to go out to your site first non-securely, unless you have that strict transport security rule. And that means it's a possible point of interception where I can respond to this with my own change password page, and boom, you've now given me your password. Another example that came up recently, so we had this big political campaign, election, and so forth last year. And people sent out fundraising mails. They're like, hey, give us $5, give us $10, you've got to support your candidate to win. And unfortunately, some of these emails were not very well designed. So some of these emails had this thing where it's like, hey, just click here and your donation will go through immediately. Now, if you're a security person, that should be making your alarm bells go off like crazy. Because what that means is that the email itself contains a link, and that link has some mechanism that will automatically take an action on behalf of the current user. Which means that if that link is disclosed on the network, anybody that requests that link can take that action. And so this political campaign was sending their donate, $20 or $200 or whatever immediately link in such a way that if the user ever clicked on it, someone on the network could see that. What made matters worse is they had a token in it, right? A one-time, well, not a one-time, I sort of blew the joke there. They had a token in it that said basically, here's who the user is, and here's the authorization to bill the $200. But their token wasn't one time, which meant the bad guy could play that token as many times as he wants. He could make you donate $2,000 to that candidate, or $2 million, or whatever threshold until your credit card company was like, this seems a little dodgy. But they were using an HTTP link. Now, it's not great to have one-time donation links that are not one-time, but when you're doing it over HTTP, that's a huge problem. There's this other notion of, in security, you really want belt and suspenders, right? You want to have both. You want to have protection in multiple ways, because sometimes you will mess up. There's a piece of software called SecureDrop. SecureDrop is this idea that, hey, news organizations like the New York Times want to be able to collect tips anonymously and securely from people. And so they have this package that runs on Tor that allows people to anonymously submit privately data to them. Pretty important to get security right here. Governments would love to be able to see who's tipping what to whom. Unfortunately, the SecureDrop installer had this problem where they forgot to verify the packages that they were installing to make sure that they were the right packages. They failed to check the signature. What made this, in my mind, an egregious failure is they decided they were going to fetch these packages over HTTP. which meant that not only were the packages not being verified to be the right ones, but anyone could intercept and replace them in transit. Now, had they been checking the packages' signatures, they would have been fine. They thought they were. They thought using HTTP would be okay because we're checking the signatures. Except, oops, despite being professionally audited, they weren't. So you want to use HTTPS everywhere you possibly can, because it can turn a bug that would be, this was a critical vulnerability, and it can turn it into a much more mild problem. If your site depends on getting refer traffic, so basically your recommendation site, your news site, you want to get credit for people sending people places. One of the challenges with that is when you go from an HTTPS page to an HTTP page, by default, browsers will drop the refer header because they don't want to leak any private information. So if you've got your YouTube video and it goes off to somebody's site, people will not see by default that the user was coming from the URL to the YouTube video. So this is a problem until everybody gets to HTTPS. So the way that we solve this problem is there's a feature called referrer policy, which is supported everywhere pretty much except for Internet Explorer, where you can say, hey, I'm an HTTPS page, but I actually want to provide a referrer to a non-secure page. And you can say, just send my domain. So don't tell the remote site exactly which video on YouTube was being watched, just tell them it's from YouTube. Or you can actually specify that you would like the full set of information. So origin is just the origin like YouTube, and then there's basically a mechanism to send the full URL. So that's another way that you can unblock the deployment. Now, one of the concerns that often arises is, well, yeah, TLS is great, blah, 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 super important, but I don't want to slow down my site. And the answer is that TLS actually offers a number of performance benefits. So the first is HTTP2. HTTP2's new version of HTTP solves many of the long-standing performance issues behind HTTP, but it requires a secure channel. And the reason it requires a secure channel is because network gateways, proxies, and other devices that are trying to sniff your traffic will very often corrupt new protocols like HTTP2. And so HTTP2, in practice, in the specification they say it doesn't really require HTTPS, but in practice, all the browsers require HTTPS. So if you want to unlock the performance of HTTP2, you've got to have HTTPS. Service Worker is a new powerful capability you saw mentioned in the keynote yesterday morning. Allows you to cache content, work offline, things like that. In order to use a service worker, you have to have a secure context. It has to be from HTTPS. Brotli compression I mentioned yesterday. Brotli compression, actually slide in a minute. So HTTP2 is available almost everywhere. 83.4% of browsers support it. Service worker available more broadly than previously, and hopefully soon everywhere, but still about 70%. Brotli is a new compression algorithm replacing gzip and gives you about 15 or 20% better compression than gzip. Brotli also requires HTTPS for the same reason that little boxes don't understand Brotli and they blow it up, and so you require HTTPS to use it. This can get you significant performance improvements through smaller requests, or smaller response sizes. New version of the TLS protocol, TLS 1.3, improves performance and security. This is something that the deployment of it has been slow because, unfortunately, while TLS does a pretty good job of preventing intermediaries from messing with traffic, there are still intermediaries that try to mess with TLS traffic. They can't see what you're downloading and things like that, but they do have some other issues around how they handle TLS. And so in some content inspection proxies and things like that, where you install the self-signed root certificate, they blow up if you have new versions of TLS enabled. So the various standards bodies have been working on how can we deploy TLS 1.3. But you can turn it on in Chrome Canary through flags. In Firefox, you can turn it on through a flag. And in Firefox Nightly, it's on by default in the current draft. But this is actually converging reasonably quickly, and we do think that we're going to be able to deploy this. TLS 1.3, in addition to some security improvements, offers performance improvements by reducing the number of round trips required to handshake and things like that. So I've got a couple more minutes, so I want to show some things that you can do with Fiddler to help your TLS deployment. So one of the things you can do is you can extend Fiddler through FiddlerScript to add information around certificates. So there's some pretty simple scripts that are off on my on GitHub, where there's a site called cert.sh crt.sh will tell you things about the certificate, which certificate transparency logs it's logged in, who it's coming from, other information around the certificate. And so this is something you can plug directly into Fiddler, and so just browse your site with Fiddler enabled, and it's going to reveal that information about your certificate. An important thing around SSL is you need to make sure that you keep your certificates current. So if you're using something like Let's Encrypt or another automated certificate authority, you've got code that's actually running on your server that at the appropriate time will go out to the certificate authority server and say, hey, I'm foo.com and I need the new version of my certificate, and it'll download the new version of your certificate and install it. But if you're not doing that, if you're on a more legacy or traditional provider, one of the things that you might want to do is get professional monitoring for your certificates. One of the things that I did back when I worked at Telerik was I just had this rule sitting inside Fiddler that said, hey, if the certificate expires anytime in the next 2 weeks and it's one of Progress or Telerik's domains, color the background row in Fiddler in red so that I can go investigate that. And so that way I can say, roughly 2 days before the cert expires, I can go ping the Telerik IT guys and be like, by the way, you're going to replace the cert this weekend, right? Because otherwise everybody's going to get locked from the HTTPS version of the site. And so this is a mechanism you can use to evaluate your own site's certificates. Sometimes I actually did this for other sites. So like I just go tweet the Azure guys and things like that. By the way, you're going to switch your cert this weekend, right? Because you can get out ahead of problems and avoid fire rules. And then the last thing that you can do with Fiddler automatically is you can identify non-secure requests. And so one of the things that's pretty common is you've got an HTTPS page that redirects to an HTTP link that either goes to a download or goes to another HTTPS page. In the browser, it's sometimes hard to see those non-secure requests in the middle of those redirection chains and so forth. And so you can write a tiny bit of FiddlerScript that says, hey, by the way, if this is an HTTP page, flag that within the session list so you can go clean that up. Now, HTTPS is a huge topic, but we have a ton of resources available. There's a migration guide that helps sites move to HTTPS. I have a domain called ytls.com that sort of sets out the case for TLS. That's where I'm going to post this deck after this talk. You can go to ytls.com and download this deck. At the past several Google I/Os, we've had talks about moving to HTTPS with step-by-step instructions, slides, content like this, and so forth. And then the last thing I want to mention and do a special shout out for is there's a book called Bulletproof SSL and TLS. It's fantastic. If you want to know the deep dive, deep grimy details of TLS protocol and all of its various arcana, this is really the book to get. It is quite comprehensive, and unlike many of the resources on the web, the author just keeps it up to date because things change in the TLS world on a pretty regular basis. And so every few months you see an update from him about the latest content. There's a newsletter that goes with the book, so if you just want to follow along with information about what's going on in the TLS ecosystem, he's got a free newsletter that sends out every month about, here's who messed up TLS this month, here's things that you might care about, and so forth. So that is the talk. Any questions? Questions? Quick poll. Who's using HTTPS already? That's actually not terrible. Yeah, so it's not a bad number. Certainly, I would like to see everybody's sites and services on HTTPS. This I gave Brian, who runs the DevReach site, a bit of a hard time about the fact that the DevReach site is not presently HTTPS. Also, the bit.ly links, they're all available over HTTPS. So if you fill out my survey, please use the HTTPS version of the link. I'm on Twitter at Eric Law, and ytls.com will have the slides. Yes?
So in addition to you guys are obviously covering the transport side of things. Mm-hmm. And are you guys looking at other aspects of the internet to kind of help with security, like DNS, for example, or aspects like that?
So does you guys being Google? Yeah, so Google is generally interested in internet security in a lot of ways. One of the, I would say, probably after HTTPS, one of our primary interests is in things around two-factor authentication. So things like using security keys and security tokens. We all use them. I've got a little thing that I have to touch on my computer to log in. Universal two-factor auth is, I think, very important. We've recently
rolled out. If you feel like you would like a higher level of security for your online accounts for Google, we offer some new ways to require additional two-factor auth and so forth for logging into Gmail and Google Docs and things like that. This is particularly interesting if you follow US politics and hacking and so forth. There are a variety of people who got phished for their credentials during the campaign and things like that. So that would be probably, I would say, our secondary thing. We have brilliant and scary smart folks who go out and hack public software and find vulnerabilities in major products that are the backbones of the internet, report vulnerabilities to those. We run fuzzing for a large number of open source projects that are critical to internet infrastructure. I just saw one today where there's this library we'd like to integrate in Chrome. We required fuzzing for everything that goes into Chrome. This is a library that's been around for a long time. And they put it through the fuzzer, and now we've got a whole stream of bugs to report to the maintainer. So yes, we're deeply interested in security in all of its facets. And from the Chrome point of view, there are a variety of things beyond HTTPS that we're doing as well. DNS is a super interesting one because DNS is hard. DNS, the sort of the thing that a lot of people are pushing for looking at is things like DNSSEC. DNSSEC has some problems that make it problematic, I guess I would say. And so Google itself, for instance, is not using DNSSEC for its domains. So DNS is challenging. There are some interesting proposals around DNS. One of the things I think that is going out for an intent to implement, I think I saw recently, is doing DNS queries over HTTPS, or sorry, over TLS. And so there are things like that that are being looked at. But yeah, it's generally, from our point of view, both in the Chrome team and Google's incorporation, is you make the assumption that you just can't rely on the benevolence of the network. All the security needs to be provided in the face of a completely hostile network, because those networks are everywhere. Thanks.
Do you recommend using HTTPS for closed networks communication? Let's say within a company,
Yeah.
which has closed.
Right. So should use HTTPS within a closed network, and I would say, yeah, generally. There's some challenges usually around certificates, like, hey, how do we get maintaining certificates? In some cases, it's super easy. Microsoft's, domain stuff, they've got a bunch of features around doing certificates for machines and automatically and keeping them up to date. I don't know as much about network management software for other platforms. But there's this question of, well, do we really need it? And the answer is, well, what's your threat model? And so previously, the model used by most sites was, okay, well, we've got this firewall and we keep all the good guys on one side of the firewall and all the bad guys on the other side of the firewall. And that approach, while historically the way that most people did, it has proven less than robust in the face of the sorts of attacks that we've seen. And so one of the models, there's a white paper on it by the guys who did it at Google, I think it's called Beyond Corp. And the general notion is that instead of doing it that way, what a better approach, more reliable approach for security is that you assume that you have control over the endpoints. And so you run software on the endpoints like antivirus and configuration checkers and update checkers and so forth that attest to the security of the endpoint. So this machine is good, but no matter what network I'm on, whether I'm plugged into the Google network via an Ethernet cable or via Wi-Fi, the assumption is that the network is bad. And the network might not be bad because, in Google, like we maintain our networks, we do a good job of it. But if somebody managed to get some box on that network that's sniffing unencrypted traffic and collecting that traffic and sending it off to a government agency that wants to do something, like it's a very fragile model if you assume everything on one side of the firewall is safe. And so generally, I would say you want to use HTTPS. There are some other things that you can do when you're in a private network situation around, like you can use IPsec and things like that. But HTTPS is understandable and I would say generally a good idea. That being said, I mean, it's really easy for me to say, stand up here and say use HTTPS for everything because it costs me nothing, and it's one of those things. But I would definitely say you should strongly consider it. Anybody else? All right. Well, I'm super excited to go figure out what the future of Fiddler is, which is the next talk across the hall. So I'm going to go to that, but I'll be around for a couple of minutes for questions if you have anything else. Thanks for coming.